All right, welcome back, everyone. Fantastic day here at ATG and the rest of the country. We've got a part 3 for you, following up on our fantastic series on stormwater design using our fantastic CTC tools and our lovely Civil 3D. I am looking forward to a great day. My name's Carl Voth, Senior Civil Technical Specialist at ATG. Make sure you reach out to us for all your Civil 3D training, your Revit training, ArcGIS training, anything that you need, we got it. All right, so we're going to do a quick overview of what happened before. You can also check out our previous links. Part 1 contained some pipe network creation tools. We created a pipe network from objects. We created it from scratch. We went over pipe rules and how to set those, layer settings within Civil 3D. We used our fantastic CTC tools to make some pipe edits. We also used the Project Explorer on those. We analyzed that gravity network within Civil 3D, went through and showed you that part mapper. That's important today as well, and some part catalog modifications and how to create some custom labels. Part 2, if you missed that one, make sure you go back and check it out again. We prepared the Civil 3D pipe network, used our catchments, created our drainage areas, and used that stage storage command. That's going to come in handy today. We imported those Civil 3D pipe networks and backgrounds into the storm modeling software. We located and in the insertion of our hydrology inputs, I also gave you some outstanding references to pull some information from NOAA. We analyzed that storm network, and we also analyzed the pond, and we generated reports to finish off our drainage. Today, we're going to be using the full-blown storm and sanitary analysis design. So we're going to combine all of those together. So first thing we're going to do is we're going to prepare our Civil 3D pipe network and our drainage areas. We're going to import those Civil 3D pipe networks and background information into SSA. We're going to create a rain gauge. We're going to analyze that system. We're going to generate some reports from it. And if time happens, we're going to show you some problems that occur with SSA and how to fix them. As always, rain on me. Yeah, that was a 1973 reference to the great Who album of Quadrophenia. All right, so we've got our little subdivision design here. We've got our pipe networks created. We've got our drainage areas here. I'm going to first double check some stuff and export this out into our pipe planner real quick to verify that all of our information is correct. Let's see, for our C system, we've got that listed. Here we go, from 19 to 18. And I'm going to go through and modify these. Let's change this to 20 real quick. No, I want that to actually go to 18. I want this one to go to 18 as well. And I'm going to apply those. Let me export that out. Yep, I'd like to create that Excel spreadsheet. Let's go over here and check out what's going on. All right, so here we've got our 19. Let me change that to 20. No, I wanted 18. 18 there, and C1 to C2. I'm going to break this down to my invert elevation 2 of 1850. Actually, that's a better one for those. All right, and then I'm just going to save out my Excel spreadsheet here, and I'm going to hit cancel on that one and import that spreadsheet back in here and make those modifications to my pipes. So let's go through and check this one. So, yeah, oops. That's the one I want. All right. Fresh. And I'm going to pick my last last pipe modification one there. There we go, 18s, import those in. And let's see what we got here. All right, cool. Really like that little handy dandy tool for some quick functionality there. All right, I'm going to now save my Civil 3D drawing here. And we are now going to go into Analyze. And we're going to analyze in our storm and sanitary analysis. And oops, got the wrong one there. Sorry about that, guys. Just close out all my other fun stuff here. All right, here we go. Let's open up Civil 3D again. Forgot I had that one linked to another one there. Little technical difficulties, but won't be too bad. We'll edit it and post. I'd like to say that our sponsor today is, not Pepsi with Peeps. Because let's face it, Pepsi was not sweet enough, so they decided to add more sugar. Choice of a new diabetic generation. All right, so edit stormwater, close out of that one. I just want my storm information. We're going to bring up our storm sanitary sewer design, and we're going to create a new project. And because our Civil 3D file already has all of our information in it, it's going to export this out through there with those mitigation settings that I showed you how to do before. So I'm just going to close out of that log file there. And we're going to come through, and right off the bat, we can see that we have our structure networks here. We've got our subbasins or catchments, drainage areas attached, and those are linked to our inlets here within SSA. We click on these, we can see what we have for that drainage area. So this one is sub C3.1. It actually shows all of our drainage areas for these basins and the areas that are being attached to them. Here in Civil 3D, we went ahead and gave it a time of concentration already from a user standpoint. And if we wanted to, we can come in and see what our weighted C on this one is. So we have a runoff coefficient of 0.5. We can also come in and manually change this runoff coefficient. And we can come through and look at our table here and see what we're using. So we're using quarter-acre lots, and we're going to run in a B-type classification for that. Change that to 0.33. And so here, now we've got our listed soil groups and our runoff coefficient for our subbasins. If we did not already do that in Civil 3D, here's where we could add that additional areas for each one of those subbasins. So I'm just going to hit close out of that one. Here we've got some additional little conveyance links here, and these are going off-site. I'm going to right-click on these and delete that off-site 3 and this off-site 3 as well. And there's our other subdivision in there. And I'll just go ahead and toss these two as well. So with our inlets here, we can double click on these little inlet structures right through here and see what's going on. This structure itself is running an FHWA HEC22 generic inlet imported in from Civil 3D. The inlet type here for the curb opening inlet is also brought in under your parts list categories in Civil 3D and its mitigation settings. So this is going to be a curb opening. And then this inlet location is set to be on grade, which means that the roadway slope coming down, you have an inlet, and then it continues to go down. So as water comes down and that inlet fills up in that curb, it will then have to bypass it and go down to the next inlet if it's listed on grade. In our case, these are going to be on sag conditions. And here we need to come through and I need to modify my curb opening length because my part catalog did not pick that up. Notice that this is in inches. So I'm going to type in 192 and I'm going to change this to a 4-inch curb opening. Go through and close out of that one. We can manually go through and then just select all of the inlets down here at the bottom. So we don't have to go through our plan view and change those. We can rapidly do these, changing these to what we need them by just selecting them down here at the bottom. And on grade, that one's 192 as well. That one's on grade. To sag. Let's put this one back on sag as well. All right, so that's that entire pipe system there for C1 to C2 for the inlets that we can change from. If we wanted to add in the gutter width, that we can go through, in this case 1.5 foot, your gutter width's that. And if you had a depression before you got to your inlet, here's where you would add that to it. So if we're running, for instance, a 4-inch curb throat opening, and then our asphalt depresses down below it, so that we have a total 6 inches, then we could come through here and add that additional 2 inches down there. So let's go through and just do that on all of these so we're consistent. And 1.5 and 2 inches, 1.5 and 2 inches. All right, and now it looks like we've taken care of all of our inlets on this section right through here. Now we need to come through, and this is going to be done under the rational method. So we're using an IDF curve. So we're just going to double click on it, verify that we're pulling from an IDF table. And if we needed to, we could load in a IDF curve. Let's go to our desktop here, and I'm going to use the IDF DB file, which was exported straight out of Atlas, so we didn't have to put in any of that information. And then we have our return periods for each one of those years involved. I'm going to go ahead and close out of that one. Now we're going to have to go through, and we have a pond here that we would also like to analyze. So right off the bat, we're going to come up here and we're going to choose our storage node. It's right next to our inlet. We can manually add more inlets if we want to. And if we need to change existing inlets, we can do that as well. But in our case, let's just go ahead and add in our pond. So now we have our pond storage node here. So we call this one Pond A. Now, here we can come through and we can add in our information that we want for our invert elevation and our maximum elevation of our pond. So if we wanted our pond to be 8 foot deep and our invert to start at 18, we could do so. And then we can set our water surface elevation if it's a wet pond here, or we can come down and then set that water surface elevation here if we have multiple ponds in our system. Now, if you look back to a couple of months ago, where we went through and used our stage storage tool in Civil 3D, we went through and pulled and defined that basin from there. Let's call this one Pond A. And I'm going to define that from surface contours. And I'm just going to select my surface there. And now all of my contour information is available for this pond. Now I'm going to go through and I'm going to export that out, and let's see, save table. And I'm going to change this from I'm going to leave this as a stage storage table. And I've already got one in here, but let's call this pond A, let's say, and hit save. And we can cancel out of that. And now I'm going to come back into storm and sanitary sewer analysis. I'm going to change the storage state to a storage curve. Down here under our storage curve, we can come through and then add a new storage curve. We're going to call this one Pond A again. And we can manually type in our information here for our areas, or we can come in and load, change our file type to stage storage table that we got from Civil 3D, and bring that one in. Now, I have some issues with mine where I picked up some zeros on my stage storage table. I'm just going to delete those out by right-clicking on the row and deleting the row, and you can see our curve and storage curve changes. All right. And then now we have all of our volumes set up here. We can also do that depth by volume. Back and set it that way. And then now, if we wanted to add any additional information to here, say we have some storage chambers, we can come through and add in chambers as well with our pond, or we could have left this blank and just done storage chambers. We can hit, and that's going to be the one with our storage chambers. That's kind of goofy. So I'm going to actually delete that one out and then bring the other one back in. So load A, delete out those rows, not a problem. All right. And we're going to close that out. Now we have our pond down here. This is a wet pond with our invert elevation at 18. We've got an 8-foot max there. I'm not going to apply any exfiltration to this system for this. It's initially going to just be a dry pond. That's why I'm not putting any water surface elevations to it. If we wanted to, if it wanted to be a wet pond, we could put that elevation in. Close out of that one. All right, so now we have our pond information here. Now we need to link this pond information from all of our systems that are being put into play here. So to do that, we're going to use a conveyance link between the two. So I'm going to have this structure go to our pond, and then I'm going to have this structure go to our pond as well. So now we have these conveyances that we can list these out. I'm just going to set this as an open channel for the now, or actually a direct connection to that pond. I'm going to set this one as a direct connection to that pond as well. All right, so now this system that we have coming in and this system are all being calculated in our pond, and each one of these has our catch basins attached to them, so our flow is calculated through. Now this system here, if you remember, is our outfall system, and we're tying into an existing ditch, and we're not really using an outlet control structure because, as we found out, that pond was oversized for this drainage area. So we're just using our pipe here as our restrictive control structure instead of actually putting in weirs. But I'm going to show you how we can go through and do that. What we can do is, if we wanted to add some orifices or the outfall of this pond, we're going to select this, and now you could, in most circumstances, where you're not tying in and you're just going into a ditch, you can just drag that to that ditch location and then it would outfall through there. I'm actually going to connect this pond to this structure here. We're going to look at this orifice. Now, this orifice here is going to be what would be orifice B if you're using the standard storm sewers, is a good way to look at that. In this case, we're going to run a 36-inch orifice, which is our outfall pipe here that we're tying into. And we're going to leave those as sides. And I'm going to hit close. So now our system is connected. It's going to run through this storage and then outfall out through here. If we wanted to, we could come back and add additional storage orifices to this. Add orifice 2. And let's say that we want a series of orifices. So we could go through and then do, let's say, 4-inch orifices over through there. And I'm going to list that one as that. So it's right there. And that elevation, I'm going to leave at 18 as well. Close that out. So let's do an initial run and see what happens and what potentially could go wrong in our analysis. So we've got some errors. Let's find out what they are. Simulation period not properly defined. So what we're going to do is we're going to go back and we're going to look at our analysis, go to our analysis options. Now, under here, we need to do a few things. We need to set our start and end date on our analysis. So this doesn't necessarily have to be correct, but I'm going to do a 24-hour event. So a 1-day situation here. We're going to then come to our storm selection. And here we can come through and select those return periods from our IDF curve. So I want my 2-year, and then I want my 10-year, 25, and 50. And let's do 100 just for fun. Now, really that error is coming from this right here, our output file name. It needs a place to go. So we're going to come through and then we're just going to set up a solution file. I'll replace that one for 2, or 10, and our 25. Now here we don't have a 50, so I'm just going to go ahead and change that, and we're going to list that as 50. And it's going to create that 50-year storm file. And then I'm going to come back and I'm going to change this one to 100. And now it's going to create that 100-year storm file. And then I'm going to run, in our case, we can run all 5 of those events at the same time. Now, let's see if that fixed our problem. Let's see what's next. It did. All right, so now we've run our initial report for our stormwater system here. We've got all of our basin totals being calculated here. We can come through and we can review what information is being put into the system. So we have our outfalls here going into our pond A, the inverts, rims for that entire system. We can come through and then look through at our gutter summaries where we've changed those to 1.5 feet and our depressions for each one of those. Our inlet locations where we change those to be on sag. It's going to also give us our rim elevations and our invert elevations for our structures. Then we're going to come through here and we're going to look at our links on which one each one is connected to. So this is going to be our pipes. and then what type they are here and the depth or the diameter that they're located at. And we're going to get down here and we're going to start going through our analysis. So here we have our HRADs, transects, and now we do have some errors down here at the bottom that B1 and B2 has more than one inlet link or outlet link. So let's go back and look at those. So I believe this is our B system here. Look at that. Let's pull up our report here. B1 to B2 has more than one inlet link. So that's going to be B1, and we do have more than two on that one because we have a catch basin here, that we did not have drainage areas associated with. So we would need to come through, and I'm just going to delete that junction out and put in a new junction here. I'm going to then modify this inlet here. That's going to be a grate inlet, rectangular. Let's see if I have slotted drain inlet. And let's go with one of those. All right, and I'll call this one B1. And oops, guess I'm not calling it B1. Let's call it B2. See if it'll let me do that one. Nope, that one's there too. B 1.1. There we go. Now we're happy. All right. We can also now include upstream roadway links to those inlets if we want. And I'm going to leave all of that the same. And now, because we've got this inlet and we deleted it out, we need to add a conveyance link to that. I'm going to go through, select this one, select that structure. We're going to come in, use our little icon here, and that's being listed now as a pipe of 18. If we need to, we could change that to 24. What our length of this is, whether or not it has a flap gate. And then here's our name of this one. So we could go from B1 to actually B1.1 to B1. And close out of that. So now that's taken care of. Now we're going to go through, look at this basin again here. And we're going to go to our runoff coefficient, make sure that's good. And we can see. Change that one around there. Okay, so, oops. Back to our sub basin here. Outlet node is C3.2. So this outlet node, we're going to go through and change this one to B1.1. So now that catchment area is now back to that grate inlet. So let's go through, let's run our report and see if we got rid of that one. Oh, now we got something else. And B1.1 has an invalid bypass link. Let's go back and see what's going on with that one. I'd be willing to bet that it's going to be because it is listed on grade and we did not have a bypass to it. Am I correct? I was. All right. So now we have our output report and we've got some more issues going on with weir diversions and invalid parameters. So oops, cancel. Close back out of that one. And we're going to change our invalid parameters back here to our storage node curve, pond A. And our conveyance link here is direct. And let's go through and see what's going on here. That one. Delete. All right. So I've gone through and then put in some slow divergence here. Let's go through and find where those are. So we can go through and look here at the bottom of our link types here. We can come through and then delete those out. And then see if we got anything else that I accidentally threw in here for the fun of it. All right, I think that should be it. Not report again. Nope. Oh, okay. So we're going to come back. I'm going to go ahead and just toss out these real quick and then redo these. There we go. All right. So run through there, connect that one. Run through there, connect that one. And then come back and then do our weird structure here. So this we're going to change back to a direct. I'm going to change this one back to direct as well. And we're going to set our outfall orifice here to 30 inches. All right, and let's run our report. Parameter specified. Well, that always looks bad. All right. So we're going to be willing to bet it's going to be with this. So let's just toss stuff here until we find out where our problem is occurring. There it was. I had a lot of stuff buckled up on top of each other at that point. Sorry about that. There we go. Now we're back to our report that we have. All right. So with that, we can then output those summary reports into our custom report options, where we can come through and set up a standard style of how we want this to look each time. So we can come through, set up our inlet summary so that we're giving it our structure name and the title, element ID if we need to. We can come through and move these up or down according to our report scenarios that we want to put in. We can also exclude them from our report. Inlet location, don't need that one. Number of inlets, don't need that one. Then we can come through with our link here. We can call it our name or element ID. Uncheck some of those. We'd like our to and froms, our links, our peak flows, reported condition, do that one. Once we're done with this, we can save these settings where we don't have to keep making these modifications over and over again. And then here with our report, we can come through and also set those up to spit out what we want them to spit out for us. And we can apply dates and times headers. So, ATG, USA, oops. can save that functionality. I'm just going to put that in here as my pipe report. Yeah. And then I'm going to, okay, oops, I'll put support options. And now let's do some of our Excel table reports here. Excel brings it up for us. Got a lot of stuff popping up here. So here we've gone through and we've got our pipe diameters, shapes, so forth of how it's been put out. Here we've got our outfalls on what elevations they're coming in at with the X and Y coordinates. I could have removed those in those reports. Our storage nodes is going to be our pond information. Our inlets are going to be each one of our catch inlets, any junctions that we have going through there, and then our orifice that we had set up, and then all of our sub basins that we have pulled from there as well. We can now take this Excel spreadsheet and this format and bring it back in with CTC and then update our pipes if we needed to modify anything within the storm and sanitary analysis. I'm just going to save this one. Lock up on here. There we go. Why are we going to OneDrive? Wow, that's a first. I crashed Excel. All right. See if we can also do a time series plot now. Let's go back to our analysis options. We're at 1, start sweeping at 1. Come through, set our rainfall data. Let's say, for instance, that we didn't do our catchments in Civil 3D. For instance, this catchment is at 6.39 acres. We could come through and we could add these subbasins in manually. And if you've noticed, let's draw those in. If we wanted to trace an area, we can do that. And then we have our catch basin there. We come back and then edit that catch basin. So what it's being traced at is at 0.3 acres. Now it's actually 6.32. And give it our time manually if we need to. And we can change it. So our weighted seed there, and we can come back here. We can add that in once again with our functionality there. That's kind of nice where you can go through. And then if you know what your soils type is or your residential section here, and just select which one that you're wanting for its percentage, then it will go ahead and update that runoff coefficient for you. And then we can close out of that one. Now that we have that one, I'm going to go ahead and delete this one out just where I don't double up on my subbasins. So that's going to be listed as sub 1. And then here we select our outlet node again. I believe that's B2. And so now it's connected those sub areas in through there. Same thing for our junctions, or if we needed to add additional inlets into here, we can come through and add an inlet into our section here, and it will split that link there or that pipe to put in that additional inlet for us. So we're going to add that one. I'm going to add another one over here. And so now we have 2 inlets. We're going to come through, select our icon cursor again, go to inlet number 3, and we can change that back to a curb opening inlet with 192 inches, 4-inch curb height, on sag condition, It's a 1.5 foot gutter, and I'm sorry, 1.5 foot gutter and a 2-inch depression. And we can come through and rename these. C 3.4. Actually, C 4. And this one's going to be C 4.1. On sag, gutter width 1.5. And all of this can be handled with the migration settings in Civil 3D instead of actually trying to come through, do these within the process. But if you're not familiar with the migration and how Civil 3D's pipe networks are set up, go back and review that other port, and you can see where we can, all of this information will be pulled from there. All right, so we're going to close out of those. Now I need to add another conveyance link between the two here. And now we have that one. Go back and select our select element function. It's going to be a pipe. I want that to be 18 inches. Because it's connected to those nodes, I just need to provide my upstream pipe elevation for it. So we do 19.85. Other conveyance nodes doesn't necessarily mean that it has to be a pipe. We can sit there and we can also, let's say, have a ditch that's running into our pond system as well. So I'm going to come through and, okay, where are you blinking? Pipe. C4 to C4. So let's go through and add another offsite catchment through here. Done. And this is going to get modified. So for ditch A, I'm going to go to runoff coefficient of residential 1.4 in our B zones. And our outlet node on that one is going to be our pond A, because our ditch is going to run, this drainage area is also just going to plummet right into pond A. Now, if we wanted to, we could come back and so now I need to add a weir to this pond and an actual outlet control structure. This first one that we chose was to add orifices. Now we can come through and add weirs to this outlet node as well. Just going to have it go over to here and here. And now we can set that weir for a box, whether or not it's a rectangular weir, side flow, transverse, or a V-notch weir to our pond. And then we can provide it with that elevation for where that weir is. So in this case, if we wanted to do a box structure before we went into our control pipe, we could come through and then do, let's set this one at 21.0, and let's set that crest length to, let's do a 18-foot crest. And I want a 5-inch weir there. And now that's been added to our system here. Show. Yep, we're good there. We'll click on that. Those modifications take place. And so now our pond first controls by the output, the orifice out, and then it gets controlled by the weir. And the reason why is because of the elevation that this one's going to be set at. So in this case, this actually needs to be at 18. No, was it 19? 19. Let's go back and set this one to, that's at 21, so that one's fine. All right, so now all of those are being modeled all at once within our system here. So let's go back, and then I'm going to apply another pipe network here to, let's do a junction from here to here, and then do our conveyance weirs from here, and then come in, change this to an open channel. Then we have our options here to change this to a trapezoidal. We can then go through and change our side slopes on each one here. So change that to 3:1 and change this one to 4:1. So now we have an irregular system going on, and a 1.5 foot depth and a 1 foot width. And that length showing at 139. If we wanted to change that to 150, we could. And then we need to give it an invert elevation. Let's say at elevation 1950 up to and out. Information at 19. And here, once again, we can choose our Manning's roughness on what that ditch is going to be. So if we needed to come through, we could do a vegetative lining, dredge channels, main channels, all of those are down through there. And so in this case, let's go through and choose a earthen ditch 0.16. Now, sadly, this does not operate like the good old C values. So you actually have to do what normal we're running here. So I'm going to come through and use 0.012. So 0.012. Right. Now, right now, it's not showing any flow properties. So let's come back and take this subbasin and change it to that junction 1. Move this. And now you can see it's connected into that ditch section. So now if we go back, look at this, our flow prop, any losses that we had going through there, we could adjust for. I'm gonna go ahead and close out of that. We'll run this puppy, see what we got. All right, subbasin SO3, downstream outlet node. Oops, didn't close out of that, did I? I did not. All right, so that would be subbasin 103. Yeah. So with that one, I don't know why I keep putting in additional subbasins. There we go. There's our report. And now we have those additional catchments put into place for our pipe networks and our catch basins. All right. And then we can come through. We can also start tracking our changes that we make to our report. And then we can go back and stop those sections as well, as we're going to, if we need to run different scenarios and see which ones we need to go through. All right, and then now I want to generate a custom report output, input summary report. It's going to be all of the sub basins that are attached here. All of our inlet nodes or catch basins. All of our junctions and outfalls are going to be listed there. And then let's go through and notify overriding. Okay. And now See if we can do a profile plot, selecting from this node to this node. So let's now go through and plot those options. And there's our profile being shown. And wow, some weird scaling options there. So as we continue to go through, we can leave these up and then make modifications to this system, whether or not it's with our inverts, or let's just get crazy here and put this down to 5. All right, and then go back to our profile plot. And then now we've got drop that down. That, close out all of those. Go back, profile plot. Starting node is going to be this one. Ending node is going to be this one. And then show that plot. No, did I not change that to 5? Thought I did. No, guess I did. Let's change this link here. Change that to 30, 30, 30, and 30. So that updates now dynamically with the modifications that we've made through our system. Yeah, right. With that, we are running out of time today. Hope you've had an outstanding day, and hopefully you can dive in a little deeper into storm and sanitary analysis without being too confused. Remember, this little green guy right here is going to be your catch basins. Those are your inlets. You have to do a junction. Your conveyance link needs to go between either a junction or a outfall or an inlet or a storage node. You just can't have them randomly out in nowhere. And then also when we come from our ponds, here's where we need to add those orifices and where that's going. So if you're going just off site, we can just add that one there. And then we can connect from this point to this point. And now that is an off-site storage conveyance, in which case then we would need to come through and then delete out these as well. And then we could also go through and daisy chain these up with junctions here and click on our storage nodes, and we can come through and modify these. So now close, let me go ahead and take this one out. Come through and let's first do a weir, or I'm sorry, an orifice from here to here. And a weir from here to here. And then now that's how that's going to be calculated within that system. So we'll go from pond, going through the weir, and then out through the orifice, out through that way. And then our outfall out to our final location there. All right. Once again, don't forget to come back and check us out next month for another exciting episode of ATG Fun with Tools. And I look forward to seeing you then. Y'all have a great day. Bye.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.